3.1 is going to talk about, let me get to it here. It's going to talk about polynomials. This section is about polynomials and rationals. And we've already talked about polynomials, so a lot of this is going to be kind of review. We're going to expand on it in 3.2. All right. But what I want to do is jump into Desmos. And we're going to take a look at graphs of polynomials. Oh, my bad. Sorry. Yep, you're right. You can't. Let me go like this. We're going to be in Desmos real shortly anyway. Graphs of polynomials. And we're going to take a look at graphs of polynomials, concentrate on what we call end behavior. Okay, talk a little bit about zeros and roots. Zeros, roots, x-intercepts, which is something that we already know. We're just going to expand on it a little bit. And the general shapes of these graphs, of these polynomials. Okay. So that's what we're going to do, all right? So like I said, we're going to jump into Desmos, and I'm just going to kind of go through some of these graphs. I'm going to give you some to graph, and we'll look at them together, and then we'll kind of summarize some things. All right, so actually, I'm going to go ahead and stop this. All right, and put in the chat. But I want to make sure you guys get into Desmos first. So I'm going to give you like about a minute here to access Desmos. And then I'm going to put things in the chat here. Okay. So let's go ahead and type that in. Now we all know what this is going to give us. Right? That is no surprise there. Okay. This is what we call, obviously, a parabola. Okay. But if I FOIL that out or expand it out, we say it has an x squared, which means it has a degree of 2. And I'm pretty darn sure I remember talking about degrees. And the degree is the highest power of that polynomial. So then we would say that that is a second degree polynomial, right? Because
can you share your Desmos screen with us, please?
I can. All right, if that works for you, then we'll do it that way. Okay.
Or do you just want us graphing it on our own Desmos or on our own Desmos?
I kind of did. I want you to be. I'd rather. I really want you to look at it, and then at some point you're going to tell me stuff. So.
Gotcha.
Is that okay that we do it that way?
Yeah, absolutely. Sorry, I just.
That's all right. No, that's fine. So, again, so this is what we call, this has a degree of 2. All right, because the highest power is an x squared. All right. So we get a U shape. All right. Now what we're going to do is on that same line, right? we're going to type in we're going to add to this equation. Okay, so we already have this in there, x plus 2 parentheses x minus 1 parentheses. Now we're going to add something else to this so that we have that. Okay, so let's add that in there.
Oh.
Lots of stuff happening now.
Right. So how would you best describe this shape?
Squiggle.
A squiggle. Okay, what's another? Give me some other ideas.
Are you saying like it's a parabola, but it's going up and down?
Okay, a parabola is going up and down. Yeah, you're right, Nathan. It is a cube function. What I'm looking for, though, is what would give me a description of the graph of it. So let me give you an idea here. So, go ahead, Carolyn. What do you got for me?
I was just gonna say it kind of looks like a parabola, an upside down parabola that turns into an upright parabola.
Okay. All right. So, go ahead.
Well, I was gonna say I think it's like a to the power of 3 function.
Yep. It is. Okay. So if a parabola gives us a u, let's think of letters. If a parabola gives us a u, what is this giving us?
An N.
An n. Okay, so this is an n shape. Now let's go back up to that. This is, by the way, a third degree because look at the x's, right? There's 1, 2, 3 of them. So if I expand that out, there's going to be x to the third. So that's why it's called a third degree. So let's, at the end of the last set of parentheses there, let's add another one. So we're going to go parentheses x plus 4 this time. Okay? Now, in front of that x plus 2, I want you to put a 0.2 in there. So this is what it's going to look like, and I'm going to put it in the chat so you know what it looks like. So the final thing is going to be 0.2. And then parentheses x plus 2, parentheses, parentheses, x minus 1, parentheses, parentheses, x minus 3. And then finally an x plus 4. All right? So that's what we want in there. Now, what does this look like?
A double there.
A W, right? And we could flip it and make it look like an M, just as easy as we can make it look like a W. But this is a W. Okay, so this is to be a fourth degree, right? 1, 2, 3, 4. All right, because we have 4 x's. Now at the very end of that one, we're going to put another set of parentheses, but this time I'm going to put an x minus, let's go 2 in there. All right. Okay. Now all of a sudden, man, it's really hard to get us to see this as a letter, right? Because it's a real mess. But in some ways, we can see there's some n's in there. All right, there's some n's in there.
What was the last one we added? Sorry.
X minus 2. X minus 2. And this one would be how many degrees? What would the degree of this one be now?
5th degree.
A 5th degree. So we should start to see a pattern, right? So if we added another set of parentheses, right? What kind of shape of a graph do we expect that we might get? Well, let's think of think of 2 and think of 4 and 6. The 2, think of that letter. You know, the 4, what was that letter? So a 6 So a 6 should give us, again, something with a U. All right? Maybe
Like a U and a W together.
like a triple U, right? Like a triple U. Yeah. So that should kind of give us an idea of, okay, wait a minute, I kind of getting this now. So if we have these even degrees, we're going to get some type of a U shape, all right? But those odds, right? When I first asked you to describe that cubic, that third degree, you said, well, it's a squiggle, all right? And that was pretty close to being right. I mean, it's an N, but that's what you're going to get for these odd types. So evens, we're going to have some type of a U, and the odds, we're going to have some type of an N. Right? That's how those are going to work. Okay, so what we're going to do now is go ahead and just click that whole thing off. And I'm going to give you another thing to look at. We're going to kind of go back to that U-shaped parabola that we had. In fact, let's just go ahead and type that in. So then that was this. I don't know if that even made it in there. Yeah, I guess it did. Yeah, I got it in there. Okay, good. Okay, so there's our U shape. All right, second degree polynomial, power is 2. Now we know it has a max or a min point, right? Does this one have a max or a min? A min, good. All right, and we know it's an absolute min. But that's also called a turning point, okay? Because what happens is that function is decreasing. Remember we talked about intervals of increasing and decreasing. Good. Okay, so it's decreasing and then it turns back up and goes to increasing. So you can see it decreasing to increasing. There's a turning point there. So they call that a turning point. Right? You know what the x-intercepts are. I know you guys can do that because you're good at that. We've learned that already. Okay, you can click on those. Let's do that same. Now let's add to this. All right, another set of parentheses. And let's go with an x. Let's just put an x in there. That one looks pretty good. Okay, there's our N shape. That's what we would expect to get. All right. But how many turning points does this have? Yeah, it has 2. Very good. All right, 2. Good. Okay, it has 2 turning points. Okay, so you're able to recognize that. And you can find the x-intercepts. Right? Everybody here should be able to do that. Okay, it's easy to click on those to see it. Let's add another set of parentheses to the end of this. And this time let's go with minus 2. All right. There's our W shape. Okay, that's what we would expect because this is an even degree. Degree is 4. All right. How many turning points does it have? Good, it has 3. 3. Yeah, x minus 2 is what you're adding to that. No, not just, it has to be x minus 2 inside parentheses. Cool. Okay, so then that has a degree of 4, but 3 turning points. Now, parabola had 1 turning point. Third degree had 2 turning points. Fourth degree has 3 turning points. If we were to add to this to make it a 5th degree, how many turning points would it be?
4.
4. See, again, we're starting to see a pattern emerge there of what this is looking like. Okay. All right, so we've learned about turning points and the general shapes of these graphs. All right. Now I want to start sharing the screen with you. All right. So let me do this. Oops. All right. Now, this is going to be a little bit confusing, okay? I'm going to take this out first. Intervals of increasing, decreasing. So we know that we always go left to right for that. So this is decreasing. Okay. This is decreasing, and then this is increasing. Those are intervals of increasing and decreasing. Now what we're going to do is talk about end behavior. So end behavior is what's happening at the ends of the functions. Okay? So for example, out at the end of this function, it's increasing. So as this x gets bigger, this thing's still increasing. As x gets very, very small, this is increasing. So we say the end behavior of this function is increasing and increasing. Now I want to show you how to write that in a little bit, but I first want you to get the feeling for what end behavior is. It's different than intervals of increasing and decreasing, okay? Because we're looking at the ends. What is this function doing as we maybe zoom out a whole bunch? All right, and it's increasing on both sides. All right, so I'm going to clear this out. And now I'm going to come over here and add another set of parentheses. I'm going to keep building on this. All right, here's this one. Okay. This is a third degree. It has two turning points. We already figured that out. The end behavior, though, as this is going up this way, we say this is increasing, but this is decreasing. Okay, increasing, decreasing. That's the end behavior of that one. Again, we're only interested in what happens if I zoom out of this. Okay, what is this thing doing? Okay, and it is going up and down. Okay, up and down. All right. So let's clear that out. And of course, we're going to add another one to this. Okay. Fourth degree. There's my W. All right. So, end behavior. Oh, I can get an arrow here. Increasing, increasing. All right. Increasing, increasing. That's what it's doing on the ends. Right? It's both increasing. Now remember, that's the same thing that the parabola was doing, right? Okay. The degree was 2, increasing, increasing. It was a U shape. This is a W. Degree is 4, increasing, increasing. When we had a cubic or a third degree, it was increasing, decreasing. So if we go up here and add another, right, what would we suspect the end behavior might be?
Decreasing, increasing.
Exactly. See, and look what, that's just exactly what's happening here. Okay, we're getting increasing, decreasing. Okay. So there's lots of stuff that goes on. This is called the end behavior. And again, I'll summarize a lot of this for you. But this is what we're looking at. So end behavior is different than intervals of increasing and decreasing. They're two different things. And that's what the hardest part is people have, is separating that out. All right. Let's go and, oh, I need to get rid of this. Okay. now we're really going to do some crazy things, but let's just concentrate on the intercept. So I'm going to see how I'm decreasing this down to here. All right, so there's my U shape. Now I'm going to square that so it looks like that. Okay. So my x-intercepts are -2 and 1. Okay. So here's what I'm going to have you do actually. I'm going to have you add a slider to this. Okay. Here, let's do this. I'm going to change my mind completely. This is really what I want to do. I want to put this in the chat. And I want to stop sharing. I'll just put it in here. So here's what we'll do. Go like this. Y equals. I want you to start with a second degree. And I want to have you add a slider to that. We'll call it, I don't know, D. Okay. Then I want you to build, so then what I want you to do then is slide this thing here. Oops, why isn't that? Oh, there we go. I want you to slide that thing up and down. Okay. And here's what I want you to take note of. How many x-intercepts you're going to have. Not what they are, but how many you're going to have. How many x-intercepts. All right. Do the same thing to a third degree. So then come down here, add a set of parentheses. How many x-intercepts do you have? And then do the same thing with a fourth degree. All right, so start with this equation here. And then, sure, then notice the number of x-intercepts. Change to a third degree and notice x-intercepts. Do the same for a fourth degree. And all you got to do to add a slider is come up here. Let me delete this so I start like this. Let's go plus and then hit a letter. And I just put D. And then click on where it says add a slider. And then you'll get it. Okay? That's all we want to do. All right. Okay. So I'm not interested in what the x-intercepts are. I want to know how many there are. Okay, so I think this is going to take us like 2 or 3 minutes. So it's 7:05. So at about 7:08, 7:09 district. So let's go 7:10. I want to come back and see what you're going to tell me. All right. Resume this and share this correctly. All right. Okay, so since this is fresh in your mind, I'm going to talk about a second degree polynomial here. Oh, here, let me get this so I can write. I'm getting lots of stuff. This is good. Second degree polynomial. Okay, I want to know the number of x-intercepts it can have. Alright, so let me see. I got all kinds of stuff here. I got, so second degree, I got 0 or 2. The same number of intercepts as the 2 fewer intercepts than the number of terms, okay? In the second degree, you'll have at most 2 can lose them, so yeah, okay. And third degree, you'll have at least 1. All right, and okay, so it looks like we're getting some great answers here. Who was that said that? That was, okay, Ashley, good. All right. So let's see if we have another response here about what they notice about the x-intercepts. And you can send them to me, just me if you want. Because some people are doing that, and that's pretty awesome. All right. So if we have a second degree, all right, let me ask you this. So I got a couple people who got this figured out. So can I have 0 x-intercepts on a deal like that? Can we have 0 x-intercepts on a second? Yes. Okay, good. Can I just have 1? Yes. Okay, good. Now, just in case, what do you mean? How can I just have 1? Because it can look like that. Okay, you can adjust the slider so it just has 1 x-intercept there. All right, can we have 2? Yes, obviously we can have 2, right? Okay, so we can have 0, 1, or 2. Now what about a third degree? Okay, here we go, x-intercepts. I actually did a nice job of generalizing that. Can we have 0? You're right, you can't. Okay, now let me show you why. Because remember that you're going to have an N shape, right? And no matter how, because this is going down and this is going up, all right, we don't have a U shape. There's no way I can raise that graph up. It's always going to have an x-intercept. And I can't sink it down either, right? And if you need me to show you that, I'll tell you. So x-intercepts, no, you're never going to have 0. You're always going to have 1. Can we have 2? Okay, I will, Sammy, in a second. Can you have 2? Yes. Yes. Okay, and I'll show you that one. Can you have 3? Okay, good. Now let me show you this. All right, so we want to come into here, and I want you to ask questions and say, hey, can you show that to me? Because this is important. All right, so if I throw in another parenthesis in here so that I have a third degree. All right, so there's a third. Let me change the color so it's different than, there you go. All right, now I'll shrink this down. So 1, 2, 3. There's 3 x-intercepts, right? So you want to see, can I have 2? And right about there is 2. I need to get this just a hair closer. Okay, and I don't know if I can, but right about there is where probably 4.05. It's pretty close. Okay, pretty close. So that's 1, 2, right? So I can have 2. I can have 1, 2, and 3 x-intercepts on that. 1, 2, and 3. Okay, that's good. All right, let's go with a fourth degree. X-intercepts. Can we have 0 x-intercepts? Oh, I got 1 no, 1 yes, and another yes, and another yes. Sure, because think about this, right? Remember, this is a fourth degree, so it's going to be something of a U shape, right? It's going to be a W, I can draw one like that. Okay, good. Yeah, you're seeing it. All right, so I can have 0 x-intercepts. Can I just have 1? Uh-oh. Sometimes. Yep, that means yes. Okay, good. 1. Can we have 2? And 3? And 4? Oh my God, one person says no to 3. Okay, hold on. One, 2, 3. Okay. All right. 1, 2, 3. So here's what we got in a nutshell here. All right, and actually you kind of said it. You're basically saying that this degree, right? First of all, do we ever have more x-intercepts than we do the degree? No. So whatever the degree is, that's how many x-intercepts there are. But there could be less, right? We're all saying there could be less. When is there only going to be 0 x-intercepts? Which degrees are going to have 0 x-intercepts? That's right, evens. And which degrees are going to have odd x-intercepts? Or 1 x-intercept? As the smallest, I should say. Odds. Okay. Evens are going to have zeros because of that U shape. Okay. So hopefully you're making that connection. Well, it's because it's a U shape. Okay. And the odd degrees are going to have 1 always, right? Because, at least 1, because of that N shape. All right. Cool. So we got it. All right. Whew. So that's important about the x-intercepts. All right. And behavior. Same thing. So if I have a second degree, all right, then we know that the end behavior is going to be which on both sides. What's it going to do? If it's a second degree, what's it going to do? End behavior increasing on both sides. All right. So if I had a function that was a second degree, all right, here's how I'm going to write that. I'm going to write that using this terminology. Now, what does this mean? Well, this, first of all, is called limit. All right? And a limit is a calculus term. So what it means basically is what is happening to a function as x approaches some sort of a number. Well, in this case, we're saying that x is approaching negative infinity. All right, so as x gets very, 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 very small, what is this function doing? So that's how we say end behavior. So the limit of f of x as x approaches negative infinity is infinity. But the same thing is going to happen when x approaches infinity positively. It's also increasing, right? Increasing, increasing. That's how we do end behavior. Right? And that's how you symbolize that, using this thing called the limit. But don't let it throw you. All it is saying is, what is this function doing as x approaches this certain value? Now, you can't approach, infinity is not a value, right? It's not a number. I can't put a number in its place, but that's what x is approaching, right? And if you take calculus, then in certain situations, x will be approaching a number. All right, what is it doing as it's approaching a number? Okay, but in this case, all we're doing is saying, hey, what happens as this function gets very, very small for x, what happens to this function as x gets very, very large for x. That's what we're doing, and that's how we say it mathematically. All right. Now, I could take this very easily, and I could flip this u, in which case we would be decreasing, right? So that would just be negative infinity. But the point is that on either side, it's both of them, either both increasing or both decreasing. All right? That's what we want to know. Okay, that's what we want to get into. Okay, so what about a third degree? Okay, so let's say we have a function that's a third degree. Okay, we want to know what the limit of x as x approaches negative infinity of f of x. Okay, well, in general, what is this function going to do? Is it going to increase or decrease on the negative side? Yeah, it's going to decrease. Okay, so we're going to say it goes to negative infinity. Most likely, right? I mean, unless we do some sort of fancy stuff to it, okay, it's falling on the left side. All right, on the negative side, it's decreasing. But what's happening on the positive side or the right side as x approaches positive infinity, what's it doing? Right, it's going to positive infinity. Right. Okay. So again, here's this even and odd degree thing, right? Even degrees, going to be doing the same thing on both sides. Odd degrees are not. All right. So you can tell a lot about a polynomial function by not even graphing it, by just looking at its degree. You can tell a lot. The only other thing here, I want to make sure that we understand, because I'm a little bit not sure about this. So the degree of a polynomial, again, is the highest, I like to say, or largest, you can put any word you want, exponent. So if we have f of x equals x to the third plus 4x squared plus 5x, that has a degree of 3 because that's your highest exponent. Okay, that's a third degree. If we have one like this, that is a second degree. All right, again, the highest exponent, whatever that is, that's your degree. Okay. And it tells you a lot about what this thing looks like. Okay, I just want you to kind of take a pause for a second here, write all this down, make sure you're getting it. If you have questions, make sure you ask. Okay, I'm going to give you another one to graph in Desmos here. All right. Go type that one in. How many x-intercepts?
2.
2. All right. What are they? What are the x-intercepts? Negative 2 and 1. Okay. Can you tell that by looking at the equation I gave you? Yes. How can we tell that that's... Yes, good. Where's it coming from? How do we know it's negative 2 and 1? Okay. You guys are saying sure, but how do I know? Tell us how you know. And chat it to everybody or say it. How do we know? Yeah, Sam, you're pretty close, right? You're just saying, hey, we're just solving for x, right? So let me share this with you real quick. I like it. Yeah, it's okay. Look at right here, right? Solving for x. So if this would be a negative 2, right? It's the opposite of that. Here, 1. Negative 2, 1. All right, negative 2 and 1. So then if I type in this equation, y equals x minus 3, all right, and x plus 1 and x plus 1/2, without graphing it, can you figure out? That's right. You're right. You're absolutely right. Look at that. Boom. 3, negative 1, and negative 1/2. If you don't believe me, check it out. Okay? You can check it out. Those are your x-intercepts. All right? Check it out if you're not sure. Those are your x-intercepts. So we say that actually that this is written in factored form. Okay, that's not in your book, by the way. But this is written in factored form. It comes up later, I think, next week. All right, or maybe this week. Anyway, it does come up. Factored form. Okay, that's giving you the factors. Now, what I'm interested in, though, I'm going to clear this out, is what's happening. I'm kind of getting rid of this color here. I don't want to use blue because that's what we use. Right here. This x-intercept is different than this x-intercept. Okay? How are these two x-intercepts? I know that they're different numbers, but graphically, how are they different? You're right. One is a turning point. Very good. Okay? One is a turning point. This one's not. This one here is at 1. Okay? Which comes from this right here. And it has a power on it. So what happens is when you have a power, is it's a turning point. So it comes down and it touches and bounces off and goes back up. All right? So we call that a double root. Sometimes that's called a double root. Okay? Your textbook refers to this as having what is called multiplicity. And it says because this is squared, this is going to come down here and touch it. Okay, it's going to touch that x-axis and bounce off. All right, so that's called a multiplicity. And in this case, it's a multiplicity of 2 because of the power. All right, this one doesn't really have a multiplicity because it is just a 1. It's just a normal straight up x-intercept. All right. Now, I want to change this. Okay. So that this is a squared. And now we have multiplicity of 2 here and a multiplicity of 2 there because it's touching and bouncing off. Right? Touches and bounces off. So that's a multiplicity of 2 and 2. Now let's change this one. So that's a 3. And you might say, well, there's nothing exciting happening there. We still have a multiplicity of 2 here. But this one doesn't look any different than when we had a multiplicity of 1. Well, you're right. It doesn't. But if you zoom in on this, it flattens out just a little tiny bit there. So it's not exactly going through it. It's kind of flattening out. It is going through it, but it's a little flatter than just normally going. So if I take that out of there, for example, okay. Oops, it doesn't like that, I don't think. There it goes. You can see here it's not flattening out, right? But as soon as I put a 3 there, now I'm getting a little more flattening out. That's a multiplicity of 3. Again, that's coming from that power. Okay, it's coming from that power there. So there's your multiplicities. All right, so I'm going to stop this here, and we'll go write that down. Get out of the way. Thank you. There we go. So if we have a graph that looks like this, and it comes down and it touches, okay, and let's say that that's at 3, we'll say this is at 2, negative, then this would be x plus 2, x minus 3 squared, okay, we say that has a multiplicity of 2, okay, because this power, and you're always going to get that turning point or bouncing off of there. If we have a graph that looks like this, say it comes down and it kind of flattens and goes like this, let's say that this is negative 4 and this is positive 1, then we would have x plus 4, right? And then x minus 1 cubed, that has a multiplicity of 3. Oh man. I'm checking to see if I covered everything there. Okay, we pretty much did. All right. So the kind of things that they're going to ask you, or that I'm going to ask you, is first of all, what a polynomial is. Okay. Now, so a polynomial is just kind of a sequence of like these expressions sort of things. Okay. A polynomial is not something that looks like this. You cannot have an x in the bottom. All right. You can have this as a polynomial. The x is not on the bottom of that. So this is not a polynomial. This is one. Okay, just say is. Any function is not a polynomial. So y equals the square root of x. Not a polynomial. You can have y equals the square root of 3 times x to the 4th. That is yes. These things in front can be pretty much anything, right? Okay, but that's where the x's are. So you kind of got to watch for that. All right, those are going to be polynomials. The other thing it's going to have you do, and I bet you can do this, is writing polynomials. given x-intercepts. So let's say that we have x-intercepts of -3, 1, and 4. Okay, and they tell you that the degree is 3. Now it's important that they tell you what the degree is, okay, because remember, you could have 3 x-intercepts for a 4th degree, a 3rd degree, a 5th degree, 6th degree. How do I know what it is unless you tell me? So they got to tell you what the degree is. All right, so let's go y equals. Now let's see if somebody can fill in the blanks for me. What's going to go in here? Okay, x plus 3, good. X minus 1. Okay, good, good, good. I'm getting lots of answers. Good. Okay, yeah, that's what you're looking at, right? Again, that's coming from here. Okay. 3, 1, 4. Notice that this is a plus 3 because again, it's the opposite. Same thing with these negatives here. It's always going to be the opposite. All right. So that's how you write them. All right. They might ask you to write a polynomial and the x-intercepts are 2 and 1, and it says this one is a multiplicity of 2. Okay, so if that's, oh, by the way, and degree is 3. All right, guys, I got to tell you that. Okay, so the degree is 3. So here's my sets of parentheses. What's going to go in here?
X minus 2, x minus 1 squared.
Yep, x minus 2, x minus 1 squared. Good. Okay, good. Yep, sweet. You got it. Okay, because this is a multiplicity of 2, so that's going to be that power. All right, that's going to be the power on there. Okay.
How do you know for sure which of those would be squared?
It will tell you. So this one says 2, 1, and the 1 has the multiplicity of 2. Okay. So if it was 2 multiplicity of 2, then 1, it would say, then you would go with the square on the 2.
Okay, gotcha.
Okay. Just looking at those. Right, that looks good. Okay, so did I give you these ones? Yes. All right, and so I'm going to show you this here. On here, it says to analyze each polynomial by following steps 1 through 5 on 1 to 11. Really, all I need you to do is, I would just say, can you tell me what the x-intercepts are? Okay, that's good. I want to go back to 211 and see what those other things are. I'm betting probably multiplicities. So, oh, and behavior. Y-intercepts we don't care too much about. Y-intercepts really don't do anything for polynomials. Finding x-intercepts, determine the zeros with the multiplicity. Well, zeros and x-intercepts are the same. Turning points, and just draw a graph. All right, so I'm okay with that, except for y-intercepts. No reason to do that. Okay, so just do end behavior, x-intercepts. 2 and 3 are going to be pretty much the same answer. Turning points, and draw a nice graph. Now this says a complete graph. That just means you want to show all the x-intercepts. All right, and I'm not too worried about scaling. All right, you just make a nice sketch. All right, just make a nice sketch of that. Okay. And that is for these guys right here. Okay, I don't know what that is. That's for these. All right. Any questions on graphs, polynomials, turning points, and behavior? All right, this would be a perfect time to talk about your next project. All right, so let me, am I sharing this screen? Let me go and show it to you. I get rid of that. Content. I didn't fix that, by the way, but I will. Project 2. Okay, so here's what we're going to do. We're going to create some sort of an artistic design using functions that you've learned in this course. You can either search or find something that interests you or create your own. This project can become very challenging and time-consuming depending on the art you choose, so you may want to look for something that is challenging but can be completed in a time frame, so keep that in mind. You will have 1 day scheduled. That's the day that it's due. I don't plan on doing anything that day except letting you work on your project thing. There's a Desmos link that will take you to some of the art, but I want to show you what some other people have done. So this is what I need. Okay, I need a link. So what you want to do is create a Desmos account if you haven't, and do all your work in there. Do not do it in my account, okay, because it's going to go away. So do it in your own. It's free. Create your own account and put all your stuff in there. When you're done, I just need the link to that, and you can either submit it. This is also in the assignment section. You can submit it that way, or you can email it to me. All right. You can only use functions we've done in class, so polynomial, exponential, logarithmic, and rational. No circles, no ellipses, no trig functions, only those. And please don't do a bunch of linears. Okay, you should really limit your linears. Those are pretty simple. So it's got to be submitted to me Monday, 8/9 for 11:15 yen. Again, I need a link. This is how it's going to be graded. Okay, I look at about how challenging it is, how many functions did you use, were the functions you used accurate to show, I don't know, oh, your design. This thing's kind of dinked up, I don't know why. Did the domain restrictions, and I'm going to show you that here in a second. I'm going to show you how to do folders here in a little bit. Was it turned in on time, and was the design complete? So those are the things that you're going to get graded on. All right, let's go take a look at how to get a design. So the first thing I'm going to do is do a search. Now I did this earlier today, so I went ahead and I always do like a crest symbol. I don't know why, I just do. So anyway, I found one that I liked. And you can do anything you want here basically, but I've picked this one. Okay. So once you find a design that you want to do, okay, and I just picked these because, I don't know, they have lots of curves in it. It's easier for me to demonstrate. But you can pick at different things, and I'll show you what some stuff has been done. Once you have that chosen, okay, what you want to do then is download the image, all right, and save it. So I already have it downloaded, so I'm all set there. I'm going to go into Desmos, all right, I'm going to clear this out. So then what I do is once I have my image downloaded, I go to this plus here. I go to image. And there it is. It's called a rebel symbol. I never knew that. And I open it up and then it puts it in there. Okay. You can change the center and move it by clicking on that. and moving it around. Okay, you can put it any place you want. You can change the width, you can change the height. Don't mess with this one though. Alright, you can change that any way you want. Alright. I'm going to get rid of it because I already have it right here. Okay, there's my crest right there. What I want to do now is I want to create, and I'm going to use some polynomials. I want to create this design. So what I'm going to do is work on creating the bottom part of this design. Alright. So what I'm thinking about is, I don't know if I want to get all of it, but I know I can probably get the bottom part of this if I make a U shape. Alright, if I make a U shape, and maybe I can get the bottom part of that. So I'm drawing it all the way up to here because these are my x-intercepts. So maybe what I do is come over here and type in an equation. So I'm going to go y equals. So I figure it's going to cross at about -5. So I'm just guessing here. So I'm going to go x plus 5. Remember, it's got to be the opposite. I'm hoping it's pretty symmetric, although maybe it is, maybe it isn't. And I'll put in x minus 5 over on this side. Now you might be saying that doesn't look anything like it. But watch what happens when I put a point in front of that. See, I'm getting pretty close. So I kind of like this. Now, you might say, well, that's not really fitting that, but it's not. However, if I go to the end of this, and remember how we added a slider? That's what I'm going to do, is I'm going to add a slider. And then I'm going to slide it. And look. Now I'm going to get pretty close to where I want it. Maybe I just need to alter this a little bit. Maybe make it a little wider. Then alter this a little bit more. And alter this a little bit more. Until I kind of get what I want. Okay. So it's a lot of playing around, all right? I might even alter this a little bit. Just slide this thing over just a little bit. Maybe make this like a -0.5. Oops. That's definitely not. Maybe I'll just leave it at 0. Okay. That's pretty good. Now you can, again, play with this as much as you want to. I want to make this a -1.4. And I played with it a little bit earlier, so you'll see what I got when I did it before. Now, so that fits on there till about, right about here maybe. So I'm going to start drawing this at -2.4, and I'm going to end it at about 2. See, it's not very good on this side. I'm not really. Maybe if we make this like a 0.2 or something. Oh, that's better. See, a lot, you just got to really play with it sometimes and get it right. And maybe drop this down to 3. Ooh, that looks pretty good. Fits it pretty good right about there and right about there. So I'd say about 1.9 on both sides. So what I'm going to do then is I'm going to tell it to only graph a certain portion. So here, and remember I'm recording this so you can watch it. So then parentheses, okay, -2 to here to x to here to 2. So that's only going to draw it whatever you want to specify it. So that would give you that part. Okay. Now maybe I want to try to get this part up here. So again, I'm thinking, well, I'm going to try drawing something that looks like this, and maybe it's going to be like a cubic so that it hits that nice curve inside there. So I'm thinking maybe negative 5.5 and negative 3 and something about negative 1. So I got to start someplace. So I'll come up here, I would go y equals parentheses x plus 5.5 parentheses x plus 3 parentheses x plus maybe a 0.8 because I can't, that doesn't look like, that's 0.8, how about that? Okay, so now what I want to do is just make this squishier. So then see, I'm going to put a 0.1 in front of it because that's going to squish it down a little bit. Maybe too much. And you can set up a slider for this, although I don't know if I would, but you can. Boy, that's pretty good. Maybe make this like about a 3. Oh man. Maybe make that like a 2.8 or something. And again, you can increase or decrease this. So I could add another slider to this. And try to slide it down. Okay, that's pretty good. So here I might scoop maybe this in a little bit more. I think you're kind of getting the idea here of what that's going to look like. All right, and then I would restrict that. I'm trying to get it to kind of curve and get this one, but I don't know if I'm going to. But I got from here to here. So I would come up to this, put in my braces, right, and start at negative 3.08, I think that was. And end it at, I don't know if it was negative 1.5. Nope. I think it was point something. Seven looked good. All right. Then the other side of this, now here I would get rid of this. I don't want that sitting in there, so I'm going to go minus 0.2. And then to get the other part, it's just going to be symmetric. So all you would do is change the signs on that, and you can get this other part here. Okay, let me clear this thing out of here so it's kind of in the way. There we go. So let me show you what some other people have done here. I'm going to stop share for just a second. Get a lot of sharing requests here. All right, so let me see here. And then I'll share it with you. So here's one. Somebody did a dog. So they ended up with 87 different little functions on here. Actually, more than that. 130 some. Okay. All right. So this is pretty dang complicated, and so I don't think I would really recommend you did something with this much detail because you're probably going to run out of time. All right, let me go find another one for you here. Let's see what this one looks like. She didn't send me a link. She just sent me a screenshot of it. That one's not very good. I can't get a link. See what we got in this one. The cat just didn't. I think he was going to do more, but he just ran out of time. I got some more here though. So to the shark again, they didn't quite finish that one up. I don't know what some of these look like, so just pulling some up that have links. Oh, there's one like that. Okay, see now they only did 46. So you can see the difference between, yeah, leave this side. Leave this side. And leave this, oops. Leave this one, let's go back to this, find some more maybe. Let's see what this one looks like. This was from a few years ago. That's a hand. I think he was telling me he ran out of time to do his too. I think this one was pretty good. It's hard for me to remember. That's a hard. There was one on here that was pretty cool. I'm trying to remember which one it was. Who did that one? This one, I think he did a... Yeah, he did a Tesla thing on that. Okay. So there's a lot of different things you can choose from. You can check that one site out. I have lots of stuff too. The other thing I want to show you is how to make a folder, because I did not do that. So let me show you how to make a folder. So to make a folder, you go plus and folder, and then you just title it. So let's say I want to title like the bottom, so I would call it bottom. Okay. And then what I want to do is put this stuff down here. Okay, and then you can maybe see the little gray line here. That tells me that's in that folder. So when I close it, it's not there. See? So when you organize your work, you can say, well, here's the bottom part that makes this, and you would put all your functions in there. So that's what I mean by folders. But you just create them right here. Okay, and it's a really great way to organize your work. All right, really good way for that. So I think that's pretty much what I was going to show you on that. Okay, again, when you pick something, it would be a probably good idea for you to run it by me. Just say, hey, this is what I'm thinking about doing. And I can pretty much tell you, yeah, I think we can complete that, or yeah, I don't know if we can. You know, it's just, you don't want to pick anything too hard. This actually wouldn't be too bad to work on. And what ends up happening is when people start working on this, they tell me, I couldn't quit. You know, they just kind of kept working on it, and you know they spent hours and they were just trying to fine tune it and everything, and you end up working on it for a while. I guess I don't know, it's kind of like a game or something. But anyhow, so something like this wouldn't be too bad. I think I have a Crest 1 I worked on. Here's the functions that I came up with. Okay, so let me show you what I did so far. There's that. Okay, so that's not bad. I got it to fit pretty well. I just had to play with it a little bit. I mean, basically, that's what you got to do. All right, you can use lines like here. You would use a line. Here would use a line. Here would use a line. Here would use a line. Rest of the time, you want to use curves, probably polynomials, but you can use. One guy used logarithms. Some people use exponentials. Anything that we learned. All right. That's what I'm saying, that it's only intense if you make it that way. So if you go out and find a design that has a lot of curves and stuff in it, then yep, it's going to be too much. So that's why I'm saying when you find something, you know, you might want to run it by me and say, hey, is this something that you think I can complete in 2 weeks? And I'd say yes or no. All right, so you know, I realize that we only have a couple of weeks, but I think this is something that people kind of like to do. So I'm going to give it to you. And, you know, like I said, you'll get a class time to work on it. And we're still set up for that. So that's my advice. Something like this isn't real bad. I think this is a doable thing. But, you know, don't everybody do it. But, you know, that one with that I first showed you had all that detail. That would have been not enough time. You won't have enough time to do it. Okay. So yeah, it's a good point you brought up. All right. I'm going to stop this. Okay. It's like 8, so it's actually about 8:05. I think with the test coming up on Wednesday and some other things, let's just push 3.2 to 8 till next Monday. I'll do some shuffling because we actually have 8.4. We just have 3.5. So we can shuffle 3.4 and 3.5 together and move 3.2. So I'll make a little changes on the syllabus and let you know what that is in the announcements, so that you know. But let's just work on 3.1. Okay, that's not going to be due till Monday, right? So you've got enough stuff to worry about right now with your test. I would start thinking about a design though. I really would, and have something maybe in your Desmos account by the end of the week. All right, think about what you want to do there. Okay. All right. So if you have anything, ask me. I'll stick around. Otherwise, I'll see you Wednesday, and I'll be checking my emails to see if you have questions on test reviews or anything.
Thank you.
Thank you. Have a great night.
Are you going to try to open that grades spreadsheet up too?
Yeah, let me go do that now. How about? No, I would be happy to do that for you, Ashley, is work through number 3 on 4.8. Let me do this. Okay, perfect.
I have another quick question too. I'm looking on the assignments at 3.1. It lists all the numbers and at the very end says odd. Does that odd apply just to the 73 through 85, or does that apply to everything?
Just 73 and 85.
Okay.
That's interesting. Okay, hopefully we fixed that. So that's the thing. You don't want to have one with a lot of straight lines. Okay, you got to have some curves. I mean, that's kind of the point. Okay, so try to find something with not a bunch of straight lines. Okay. Let's see. So I got a couple people sticking around, want to know some. Let's see. We've got, sorry, I see Ashley, you said number 3 on 4.8. So let me share that. I'm going to stop this.